All right, let's talk about how this robot works. So first of all, we've got these two rails right here, the positive rail and the negative rail. Notice they are hooked up to main power. They're hooked up to the battery pack. A huge consideration is these two are full power. These two are 9 volts. I have these two rails used for 5 volts coming out of the Arduino. Do not mix them or things explode. Another thing that can explode is this capacitor right here. So this capacitor, if you check it out, on one side of it, it's got negative signs. Make sure the negative signs are touching the negative rail or it will explode. That's bad. All right, so let's really go over this 9-volt rails because they're the ones that can break everything if you connect them poorly. So if you check out this one, going from the positive rail to V in on the Nano, this little thing's called V in. Shockingly, it's voltage input. So we put our full 9 volts to V input because that's connected to a voltage regulator. And that is the one pin on this sucker that can handle full power, nothing else. This guy right here, we're connecting our ground rail connected to the negative terminal of our battery to one of the grounds. So now our Arduino is fully powered. So that's all we got connected here. Also notice we got connected to the plus 5 volt rail from the Arduino. It is connected to the other positive rail on this side. So this will be provided with plus 5 volt power. All right, let's see what else we're doing on this side. Right here, if you look at where it's connected, it is connected right there. It is connected to one of the heat sinks and grounds. So this just grounds our power supply. So we're providing full power to our chip. Also notice this second wire goes from the positive rail to this line right here, this far pin. And make sure you've got the indent correctly placed. Because if the chip is backwards, it explodes or catches on fire or melts. It's bad. Anyway, so this is VCC2. That is the full power you want to put to the motors. This can handle 9 volts. Most other pins cannot without burning out this chip. So we want to give it the power we want to be able to give to the motors. And then if you check out this wire, this is the to enable, or not enable, it's the A. So this determines whether this 2Y here is plus 5 volt or plus 9 volts or plus 0 volts. So if this is positive 5 volts, this will be plus 9, and this goes to your motor. If you check this out, this Y, all the Y's, they're the ones that are connected to your motors. I say, why would you possibly connect a Y to your Arduino? A for Arduino, they connect back to the Arduino to a digital pin. And Y to the motors, because why would you ever connect that to an Arduino? Then we got the same thing going on here. This guy is another Y. It's one Y here, and it's connected to this motor. Definitely have both Ys on one side of the chip connected to the same motor, because they will be handled by the same enable. We got the other A connected back to Arduino pin. And then we also have our enable pin right here connected to an Arduino pin that is capable of analog write. So it's got to be capable of pulse width modulation, because by pulse width modulating the enable line, we're turning it on and off very quickly, and that lets us control speed and power. That also means that turning on and off quickly makes our voltage supply vary a bit. That's why we got this capacitor. It's like a little battery. So it stores stuff up when power is high, and it discharges power when power is low. So it kind of evens out the power supply and potentially stops things from acting funny. If you took it out, it would probably work fine too, but it just makes it more likely to. And we got exactly the same thing going on the other side. We got our enable, which is again connected to the Arduino to a pulse width modulating one. So this guy right here. We got this one, that's an A. It's connected to a digital pin on your Arduino, which will control if this side of the motor is plus or minus, if this is plus or minus. So plus 5 volts here or 0 volts here determines whether it's plus 9 volts here or 0 volts here. And then we got a ground from our plus 5 volt supply, which we probably don't need, but may as well double ground it right here. And then we go to another Y or 4Y that's connected to the other side of the battery. As again, why would you ever connect a Y to an Arduino? That would be terrible. And then we got another A, which controls our what if this is plus 9 volts or 0 volts, and that goes to a different digital pin on the Arduino. We're using a lot of our Arduino pins just to control our motors. And then we got VCC1. This is the voltage. It takes plus 5 volts. Don't ever put plus 9 volts. This controls the internal control electronics of your H-bridge. It can't handle 9 volts. The 9 volts is just for the motors and just for the Ys. So this one we connect to our plus 5 volts. Aside from that, notice I have some other wires going here, which we will later use to control Bluetooth. If you have your Bluetooth chip in, you cannot, it overrides the send receive from the USB, so you can't download a new program. So every time, if you're using Bluetooth, every time you want to download a new program or change something, you gotta pull out your chip and then plug in the USB, download it, and then put your chip back in. So that's a little annoying, but much better if you know what's going on. Right here, we're connecting a ground to our ground rail, just so that's grounded and we can use that for other things. And then all of these wires here are connected to either A's to control whether a Y is plus 9 volts or 0 volts, or enables, which we use analog right pulse width modulation to control the power of for a single motor, a whole side of the thing. So our enables are, looks like we are connected to D10, and our other enable is D9. If you switch those, you just got to switch the code. It's not a big deal. But again, all of these wires here are just connected to A's or enables. And that's the whole robot aside from our ultrasonic sensor. The ultrasonic sensor, it's got some labeled pins. The VCC pin, you connect to plus 5 volts, not plus 9, plus 5. The ground pin you connect to ground on your plus 5 rail, though it would probably work on either rail, but just make sure your VCC is connected to plus 5, not plus 9. And then your trigger and echo, you just need to connect to some free pins. It doesn't really matter. It just changes which pin you're using for trigger and what pin you're using for echo in your code. Trigger sends the pulse. So this is a sonar sensor. It sends a sound wave and then figures out when the receiver receives the sound wave back. So you just need 2 pins, one to say, hey, make the sound wave, and one to say, hey, I received the sound wave. And so use those 2 pins there. And that is the whole robot circuit. I hope you're as riveted as I am.